Welcome to this explainer. Look, if you work in IT support or QA, you already know the absolute agony of getting a ticket from a user that just says it broke. Or maybe you've spent hours scrolling through endless front-end logs that tell you absolutely nothing useful. Well, today, we are going to seriously upgrade your debugging skills. It is time to move away from all that guesswork and get into precision, evidence-based debugging using Charles Proxy. Let's get into it. But before we even launch the tool, let's ask a really important question. Why do we actually need a dedicated traffic interceptor in the first place? Why not just use our trusty browser DevTools? Think about your current workflow for a second. Are you heavily relying on hitting F12 to solve everything? Okay, let's dive into this. Browser DevTools? Absolutely fantastic for web development, no doubt. But they have a huge limitation. They are locked to a single browser tab. They offer literally zero native support for intercepting traffic coming from a mobile app. Charles Proxy, on the other hand, is a system-wide interceptor. It doesn't care if the traffic is coming from a Chrome tab, a hidden background service, or a native iOS app on a physical phone. It catches the whole shebang, giving you incredible visibility and manipulation power over everything leaving your device. So here's our game plan for today. It's highly practical. We'll start by moving beyond basic browser tools, then get into the weeds of setting up SSL proxying. After that, we'll look at reading and filtering requests, doing some live debugging with breakpoints, and finally, we'll tackle a real-world payment failed scenario to put it all together. All right, part one, beyond browser tools. So what actually is Charles? At its core, it's basically a man-in-the-middle, or MITM, web debugging proxy. When you fire it up, Charles creates a local proxy server right there on your machine, usually sitting quietly on port 8088. Once your system or your mobile device is told to route its traffic through that port, Charles catches every single HTTP and HTTPS request before it ever hits the internet. And it catches every response before it reaches your app. It's basically a wiretap for your own network traffic, letting you see the raw, unfiltered data being exchanged. Moving right along to part two, setting up SSL Proxying. And this brilliantly illustrates why this step is an absolute game changer. Without SSL proxying enabled, all you're going to see is encrypted tunnel noise. Literal binary gibberish. You'll know a network request happened, sure, but the actual payload is completely locked away. But once Charles is trusted as a man in the middle, it decrypts that secured traffic on the fly. Suddenly you go from random noise to beautifully readable, syntax-highlighted JSON, formatted payloads, and crystal clear headers. So how do we actually get that sweet, decrypted view? Well, if you're working on an iOS simulator, it's honestly a breeze. You just pop open the Help menu, navigate down to SSL Proxying, and select Install Charles Root Certificate. Now, a quick heads up here, and this is absolutely crucial. You must quit and entirely restart your iOS simulator for it to actually pick up that new certificate. Once it reboots, just make sure SSL Proxying is enabled in your Charles settings and you are good to go. Now, if you're dealing with a physical Android device, things get a tiny bit more involved, especially for modern Android versions. Starting way back with Android N, apps actually stopped trusting user-installed certificates by default. So your dev team needs to add a network security config.xml file to the app's debug build just to explicitly trust those user certs. Once you've got that special build, connect your Android device to the exact same Wi-Fi network as your computer. Then, dive into your Wi-Fi settings, set the proxy to manual, and point it to your computer's IP address on port 8888. Finally, open a browser on the phone, head over to chls.pro/SSL to grab the Charles certificate and manually trust it in the Android security settings. Okay, part three, reading and filtering all those requests. Look, a modern mobile app is going to blast out hundreds of background analytics and tracking requests a minute. It's a complete nightmare to sort through manually. To cut through all that noise, you'll want to lean heavily on the structure view combined with the focus feature. You literally right-click the domain of the API you actually care about, hit focus, and Charles magically hides all that extra clutter under an other hosts folder. Out of sight, out of mind. You can also use the filter bar down at the bottom to search for a very specific endpoint, like /checkout, to narrow things down even further. Which brings us to part four, live debugging with breakpoints. Think of a breakpoint like freezing time. It's an incredibly cool feature that pauses a specific network request mid-flight before it ever hits the server, or it pauses the server's response before it gets back to your mobile app. While time is frozen, you can poke around the headers, read the JSON body, actually edit them to say whatever you want, and then allow that modified data to proceed on its way. Let's move to and see how this builds into a practical workflow. First up, you right-click your target request URL and hit breakpoints. Next, grab your mobile app and trigger the action. Instantly, Charles pulls focus and opens a tab with your paused request. You can literally go in and change a value right there in the JSON payload, like, say, changing an item quantity or swapping a user role, and then hit execute to send your tampered data straight to the server. It's basically a cheat code for testing edge cases without needing any backend changes whatsoever. All right, part 5, let's tackle a real scenario, the dreaded payment failed error. Picture this. You get a ticket from a super frustrated user. They write, "I tried to check out on the mobile app, but it just says payment failed." Look, if you're only relying on the UI, you have absolutely nothing to go on here. Is the backend down entirely? Did their credit card expire? Is the app itself sending garbage data? We need hard evidence, not guesswork. So we fire up Charles and execute a rapid triage strategy. First thing, we start recording and use the filter bar to isolate our checkout API domain. Next, we replicate the exact steps the user took on our proxy-connected mobile device and we hit that checkout button. We keep our eyes on Charles and boom, immediately we see a request flagged in red. It's a 400 bad request. Finally, we click into the Contents tab to analyze the decrypted JSON response body that the server kicked back. Now, what's really interesting here is how fast the mystery completely vanishes. Because we have SSL Proxying enabled, we aren't guessing anymore. We look at the raw response, and the server tells us straight up exactly what went wrong. Missing authorization header. The front-end app literally dropped the payment token. It wasn't a bank decline, it was a malformed client request. Boom, mystery solved. By using Charles Proxy to intercept that mobile traffic, isolating the specific API call, and reading the decrypted error payload, finding the definitive root cause of an incredibly vague error took us less than 3 minutes. Seriously, under 3 minutes. You can now just snap a screenshot of that exact payload, attach it to a Jira ticket, and hand the developer the undeniable evidence they need to fix it. That right there is the pure power of a traffic interceptor. It literally transforms you from a passive observer guessing at UI bugs into an active evidence-gathering investigator. So now that you know how to set up SSL proxying, filter out the noise, and manipulate the invisible data powering your mobile ops, what hidden bugs will you uncover today? Go launch Charles Proxy on your machine, connect your device, and go find out for yourself. Thanks for hanging out with me on this explainer, and hey, happy debugging.